Welcome, focused learners, to this explainer. Today, we are acting like paleontologists. We are carefully digging through the fossil layers, those tricky, multi-part exam questions, to reconstruct a complete, perfect answer. Whether you are building your foundational mathematics skills in the 0580 syllabus, pushing through the rigorous demands of 0606, 4024, 4037, or 4040, or tackling the absolute heavyweight Cambridge AS and A-level mathematics 9709 syllabus, this strategy applies to you. Today, we are specifically focusing on the notoriously challenging topic of parametric and implicit differentiation. I want you to imagine a real Cambridge mathematics past paper question. We are talking about a complex implicit curve, something like x cubed plus y cubed equals 3xy. You've got the clock ticking, tension building, and the pressure is on. Let me introduce you to two very different students facing this exact problem. First, there's Alex. Now, Alex panics and overloads the paper with raw mathematics facts. He's writing down the equation of a straight line, the quadratic formula, tangent rules, just dumping every fact he knows with absolutely zero analysis. Then there's Sam. Sam rushes. Sam ignores the product rule on the right side of the equation, entirely misses the specific command word requirements, and just blasts through to a completely wrong final answer. Side by side, their papers are covered in red pen marks. If you've ever felt like Alex or Sam staring at these multi-stage calculus problems, wondering how to consistently crack them, you are in exactly the right place. We are going to reconstruct the way you handle these papers.
Okay, let's dive into this with a number that should immediately grab your attention: 15. Parametric and implicit differentiation accounts for approximately 15% of the total marks in Paper 2. Think about that for a second. That is a massive portion of your grade, resting entirely on your ability to navigate this single topic. When Alex dumps random formulas, or when Sam rushes and misses the command words, they aren't just losing a mark or two, they are throwing away an entire grade boundary. It's a high-stakes area. Mastering it isn't just about passing, it's about securing a top-tier grade. You have to recognize that the examiner isn't just testing if you know calculus, they're testing if you can perform under pressure, deconstruct a complex problem, and logically piece together a solution layer by layer, just like a paleontologist uncovering a fossil.
Here is how we'll reconstruct our methodology today. 1. The 15% stakes. 2. Mastering core principles. 3. The method mark strategy. 4. Avoiding examiner traps. And 5. Evaluate and succeed. Let's get right into it.
Section 1. The 15% stakes.
The immense value of this topic means you cannot afford a casual review. Knowing the mathematical calculations is only half the battle. Cambridge's academic benchmarks strictly require logical, structured reasoning. They heavily prioritize analytical depth over superficial breadth. Remember our student Alex? Alex represents superficial breadth. He knows a lot of formulas, but he has no idea how to apply them deeply to the problem at hand. Sam, on the other hand, lacks analytical depth because he ignores the structural requirements of the question. To fix this, we are going to introduce the Peel framework, adapted specifically for mathematics. Point, evidence, explanation, link. Point, state the mathematical rule or method you are about to use, like the chain rule. Evidence, show the explicit substitution of your variables. Explanation, write out the clear step-by-step algebraic manipulation. Link, tie your final numerical answer directly back to the specific context of the question. When you structure your answers this way, you guarantee analytical depth. Before we continue, subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2. Mastering core principles.
To achieve that analytical depth and effectively use the PELL framework, we need to completely break down the Cambridge command words. The syllabus targets 3 distinct cognitive domains represented here: knowledge and understanding, application, and analysis. When a question says state or write down, that's purely knowledge. But when it says show that or calculate or derive, we are moving into application and analysis. If a question says show that the gradient of the curve is 0, you cannot just write down 0. The command word show that specifically means the examiner already gave you the answer and all the marks are awarded for the explicit, logical journey to get there. Sam lost all his marks because he ignored the show that command word. He just tried to do it all in his head. You have to decode these command words to prove your fundamental understanding.
Top students don't just memorize,
They exhibit a connected, conceptual understanding that is transferable to unfamiliar contexts. Now let's look at the transformation. We are going to have Alex and Sam rewrite their answers live. For Alex, instead of a page full of random equations, we guide him to use our mathematics success blueprint. He stops, looks at the implicit function, and writes his point. Differentiate with respect to x using the product rule. Instantly, his red marks start turning to green check marks. He provides evidence by differentiating term by term. For Sam, we force him to slow down. The command word is evaluate, so Sam writes out his explanation step, showing the exact substitution of coordinates into his derivative. He then links it to the final answer. Seeing those red pen marks transform to green check marks is what the mathematics success blueprint is all about. It's about transferring your knowledge to any curve they throw at you.
Section 3. The Method Mark Strategy.
If there is one thing you take away from this explainer, let it be this strategy. Cambridge rewards the journey of your mathematics. Here is that problem-solving methodology broken down. Step 1. Deconstruct the given information. Step 2. Solve systematically. Step 3. Evaluate for reasonableness. Let's do a 60-second rewrite attempt right now in your head. Imagine a parametric equation where x equals t squared and y equals 2t. The command word is find the exact gradient when t equals 2. Step 1. Deconstruct. We need dy over dx. That means we need dy over dt divided by dx over dt. Step 2. Solve systematically. Differentiate x to get 2t. Differentiate y to get 2. Divide them to get 1 over t. Plug in 2. The answer is 1/2. Step 3. Evaluate. Does a positive gradient make sense for this curve? Yes. This deconstruct, solve, evaluate loop, combined with your Peel structure, is the heartbeat of the method mark strategy.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into our interactive workshop. First up, the data scan challenge. I'm putting 60 seconds on the visual clock. Imagine a complex data table showing the values of a parametric curve at different time intervals. You need to extract the core trend. Look at where the x values stop increasing and start decreasing. That point right there, that turning point, is where dx over dt equals 0. Professional skills require you to apply correct formats and extract from texts and tables rapidly. If you can't spot that turning point in the data scan, you'll struggle to set up your calculus equations correctly. Challenge 2 in our workshop. Find the flaw. I want you to listen to this flawed sample paragraph from Sam. To find the gradient of x squared plus y squared equals 25, I differentiated to get 2x plus 2y equals 0, so dy by dx equals negative x over y. Time's up. Did you spot the flaw? Let's look at the examiner commentary. Sam completely missed the implicit differentiation notation on the y term. It should be 2y times dy by dx. Because he didn't write out his methodical working, he didn't realize he missed the chain rule application. Remember this quote from the examiner? Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. If Sam had written apply chain rule to y squared, he might have caught his mistake, or at least earned a method mark.
Section 4. Avoiding examiner traps. We've dug through the principal examiner reports, and we have to ask, why do students lose marks in multi-stage analysis? This brings us to Challenge 3, speed writing. You have 30 seconds on the clock to mentally construct a perfect Peel paragraph for the final part of a question asking for the normal to a curve. Go. You should be thinking, point. To find the normal, I need the negative reciprocal of the tangent gradient. Evidence. The tangent gradient is 2, therefore the normal gradient is negative 1/2. Explanation. I will substitute this gradient and the given coordinate into the line equation y minus y1 equals m times x minus x1. Link. Therefore, the exact equation of the normal is x plus 2y minus 5 equals 0. Boom. That is how you avoid losing marks in multi-stage analysis. You structure your thoughts so the examiner can follow every single logical step.
So let's formalize this into our final system. Here are the top 3 mistakes from the examiner reports. Number 1, using the wrong approach. Number 2, forgetting format checks. Number 3, answers not specific to the context. To combat this, you need our 3 rules that guarantee top marks. Rule 1, command word decoding. Never start writing until you know exactly what the verb in the question is demanding. Rule 2, Peel framework application. Structure your math like a logical argument. Point, evidence, explanation, link. Rule 3, the time management matrix. Do not spend 10 minutes on a 3-mark question. Look at the marks available. They dictate the depth of the layers you need to dig through. If it's a 6-mark implicit differentiation question, you know you need a massive multi-stage explanation.
Section 5. Evaluate and succeed.
This is the final stage of exam mastery. You must move up these structural levels. Start at descriptive. Identify the variables and the equations. Move to analytical. Break it into logical steps using Peel. But the top tier, the A-star tier, is evaluative. This demands that you evaluate alternatives. When faced with a complex parametric equation, you evaluate whether it's easier to find dy by dx parametrically or if it's faster to eliminate the parameter t first to make a Cartesian equation. You compare approaches and justify your methodology based on the context of the specific question.
Top-scoring candidates consistently question assumptions and justify decisions with evidence. And listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries. But only if they practice consistently with our weekly videos. You can't just watch this once. You have to train your brain to approach every single past paper with this paleontologist mindset. You have to hunt for the command words, apply the Peel framework, and utilize the time management matrix until it becomes second nature.
So, I leave you with this final question. How will you reconstruct your methodology for the next past paper? Will you be like Alex and Sam, or will you use the analytical framework we've built today? Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.